Hey, hi everybody. So in this video, we're going to solve the equation 2x minus 1, all divided by x squared minus x, plus 4 is equal to x divided by the binomial x minus 1. Now, one of the first things I want to do is I want to identify the non-permissibles. But, and this is one of the first times that we've done a question in this little series here, where there's a little bit of factoring that needs to go on here. That first denominator, there's just a little bit of factoring that I can do to help simplify this a little bit. I can take out a common x there. Then I've got the plus 4 is equal to, and there's really not much else I can do. Once that's done, now what I'm looking at here is each kind of expression as an individual factor in the denominator. I cannot let those go to 0. So I've got an x sitting by itself in that first denominator. I cannot let that go to 0. And then I have got, in two different terms, an x minus 1 in the denominator, which means I cannot allow x minus 1 to go to 0. And that means x cannot be equal to positive 1. So those are my two restrictions. I cannot let x go to 0 or 1. Now what I want to do is I'm going to, if I can, I'm going to simplify here, and I can't. I was really hoping that I could cancel a little bit here. Notice that I cannot cancel, okay? I cannot cancel those two. The reason I cannot do that is because there's a 2 in front of the x in the numerator. And so as a result, those are not the same. Okay? So don't make that a mistake by assuming that those are the same here. They have to be, you want to factor those things apart and cancel factors, and those two factors are not the same, or those two expressions are not the same. So what I'm going to do is I am now going to multiply by my common denominator, which in this case is simply going to be the product of the two denominators that or the two expressions in the denominator, which makes it identical to the very first denominator there. So that actually works out great, because when I multiply that out, in that first term there, I'm just going to be left with the numerator. So 2x minus 1. In the next one, there is no denominator to cancel, so it's just all going to get multiplied together. So 4 times the x minus 1. But on the right-hand side, and this is kind of a nice one, the x minus 1s will cancel, and I'm simply left with x times x, which is x squared. It's very easy to forget that that's got to become x squared. So now I've got 2x minus 1. I'm going to multiply this out. I'll get 4x squared minus 4x is equal to x squared. Okay, so now I'm going to bring the x squared over. I've got that 4x squared, so it becomes 3x squared. I've got a 2x minus a 4x, so minus 2x. And I've got that minus 1 left over is equal to 0. So I've got this nice little quadratic here. Well, can I factor that? Let's just take a quick look here. Is it possible to factor that? Now, the nice thing about this is that if I can factor it, I should be able to get to it pretty quick, because I've got a 3 there, which is a prime, which means there's only one way I can break that down. That's 3 and 1. And then the 1 over here, well, I love that, because that means that those two terms there have to be 1s. Okay, so now I've got this 3x times 1 and a 1 times an x there. I just need those to combine to get me a negative 2. And I can do that if it's negative 1 here and positive 1 here, because then I would get negative 3 plus 1. There's my negative 2. But anytime I do that, I really want to check to make sure that I haven't messed up the signs here. When I multiply that 1 by that negative 1 there, do I get that negative 1 at the end? And the answer is yes, I do. Okay, so that's important that we do that. Because sometimes I've seen students that have worked it and they've got that middle term to pop out, but they fiddled with the signs, and now that last product isn't coming out. Anyway, so now we're going to set each factor equal to 0, because that's really the only way that the overall product can equal 0 is if one of those factors is 0. So here we get 3x is equal to negative 1, x is equal to negative 1/3, and then over here, x is equal to 1. Two answers. That's awesome. However, that x equals 1, that is a non-permissible. Okay, so this is an extraneous root. Okay, that one popped, whoops, whoa, what happened there? This one popped out, but it's not actually a root to the equation because it's a non-permissible. So the only solution that I get here is actually x is equal to negative 1/3.